In this video, we're going to talk about how different parts of an application work together and how they can sometimes get in each other's way. We're going to look at coupling and decoupling, what they actually mean, why they matter, and how they affect the way we build modern applications. Modern applications aren't just made of a single piece of code anymore. They're built from many different parts: databases, APIs, user interfaces, payment systems, notifications, and more. The way these parts work, whether they're dependent on each other or able to operate independently, has a huge impact on the system's performance and reliability. When components are heavily dependent on one another, we say the architecture is tightly coupled. But when components can keep working on their own without waiting on the others, we say the architecture is loosely coupled. Let's start with tightly coupled architectures. You'll usually find tightly coupled architectures in older systems, especially monolithic applications. A monolith is an application where all the features and components, like the database, business logic, and user interface, are packaged together in one big unit. Because everything is connected so closely, even a small issue in one part can ripple across the entire system. Let me give you another example. Imagine an online store during a huge sale. The payment system is processing transactions quickly, but let's say the inventory database responsible for keeping track of how many items are left can't keep up with the surge. Pretty soon, the database can't keep up and gets overloaded. When that happens, the entire application starts to lag or even crash altogether. This is a real weakness of a tightly coupled design. If one piece falls behind, the chain reaction can pull the whole system down. Now, on the other hand, a loosely coupled architecture is the design style we see in most modern microservices-based architectures. Instead of everything being locked together, each component is able to run independently. That means if one service is delayed or even goes down, the others don't have to stop. They keep doing their jobs. Data and messages are passed between components in a way that avoids bottlenecks, so the application continues working as much as it possibly can. Even when one piece struggles, the rest of the system keeps moving forward instead of collapsing altogether. Loose coupling brings some major benefits to you, including greater flexibility, the ability to update or replace components without disrupting the entire system, and most importantly, applications that can scale, recover, and adapt much more effectively. So when designing a loosely coupled architecture, there are a few common patterns that can help components independent. One approach is queuing. In queuing, messages are placed in a line so that each service can pick them up at its own pace. This prevents faster components from overwhelming slower ones. Another approach is having notifications, where a single event can be broadcast to multiple parts of the system at once, making sure everyone who needs the update gets it. Or generally building an event-driven design, where components respond to specific events as they happen. This allows systems to be more dynamic and reactive. AWS has dedicated services for addressing these patterns, like SQS for queuing, SNS for notifications, and EventBridge for event-driven designs. Each of them is built to handle a specific type of communication between components and helps keep your architecture loosely coupled. We will cover these services in more detail in separate videos, but for now it's good for you to know that these are the building blocks that make loosely coupled systems possible. And remember, loosely coupled systems are the foundation for building applications that are more reliable, scalable, and truly cloud-friendly. Alright, that's it for this video, everyone. Thank you so much for watching. Please make sure you subscribe to our YouTube channel, and I'll see you in the next video.